Hello everyone, my name is Ruhan, and now I will introduce my method that I use to solve the question 2 on homework 3. On the question 2, we have the x is a uniform distribution and y equals to x squared. The first question is to ask us to find and draw small fx and big fx. Since x is a uniform distribution in A and B, we can easily draw the distribution functions like this, with the lower bound equals to A and upper bound equals to B. And the height is 1 over B minus A because we need to make sure that the area in this shaded area equals to 1. So we can easily write the functions according to this graph, which is fx equals to 1 over b minus a when x smaller equals to b and larger or equals to a, and fx equals to 0 when x picked other values. And then we can do the integrate to the small fx to get the big fx. So we can get the big fx equals to 0 when x smaller than a, because look at this area. When x smaller than a, the fx equals to 0, so the integrate equals to 0. And then when x between the a and the b, we can get the values equals to the big fx value equals to x minus a divide b minus a. And when x is larger than b, so the accumulation probability equals to 1 because it's convert all the area of fx. So we can draw the graph of big fx according to these three conditions, which is like this. And the question 2 is to find the small fi and big fi, and then find the expectation of big Y. Since a equals to minus 1 and b equals to 3, we can draw the fx functions, which is here. And we can, since y equals to x squared, we can apply the small fi, which is fx when x equals to x1, and divide the differential of gx when x equals to x1, which is x1, x2, and is the root of the y equals to fx squared. Since x can only pick the value from minus 1 to plus 3, so as we can see in this graph, when y smaller than 1, we have two roots on this graph, and when x is larger than 1, we only have one root. So we have two conditions. First is y smaller than 1 and larger than 0. We have two roots, which is x equal to minus and plus y squared, y's root. So we apply these values in these functions and get this. And we can get this. f small y equals to 1 over 4 y root. And if y is smaller than 9 and larger than 1, there is only one root, which is x equals to y root. So we can get fy equal to this. Let's combine the two conditions together, and we can get the function of fy, small fy, and according to these functions, we can draw the graph of small fy. In order to get the big fy, we can do the integrate of small fy based on dy. Fy tau based on d tau. So we can also get the big fy's function, which is listed here. And according to these functions, we can draw the graph of big fy. So we can write all these four functions, and these four functions combined together use the step functions, which is like this. We can combine the different conditions by using the step functions. So the final step is we are going to find the exponential of y. Apply the mean value functions, which is y times small fy. We can do the integrate and apply the different conditions, which is y smaller than 1 and y smaller than 9 and larger than 1. We get 4 different integrate, and we can do some calculations at the result. We can get the result. At the result, we have the ey value, ey equals to 7/3. That's all. Thank you.